Welcome back to the Elements of Deep Sea Mining. I'm Eric Young. My guest today is Anna Lim, a geophysicist who, as manager and discipline lead for deep ocean space exploration at Argeo, has led real-world deep ocean exploration campaigns. Anna's work is about turning raw sensor data into decisions that actually matter: where to map, what to sample, and what's signal versus noise.
The most important is really being acutely aware that this data set that we're looking at to make the decisions have their history, right? All of the data has its story along with it, the assumptions, the limitations, the decisions that we made at the time of survey.
We get into what exploration looks like, coverage versus resolution trade-offs, good versus bad data, survivorship bias in discoveries, and why trust shows up everywhere, from calibration to interpretation to policy. If you want to understand how science beneath the surface shapes choices above it, here's my conversation with Dr. Anna Lim.
Unless you're an experienced podcaster, which I'm not.
You and me both. Okay. Then, I have pressed the recording button. So welcome to the Elements of Deep Sea Mining podcast. Anna Lim, thank you for being here.
Thanks for having me.
So you are here as an experienced, what would you say? You've got experience running exploration campaigns and gathering real data that gets used by kind of real companies and decision makers in the deep sea mining sphere. So I'm very interested to talk to you about what exploration actually looks like from a technological perspective. What are the kind of important aspects, the nuances, the challenges of getting data? What's the difference between kind of good data and bad data? And also what it actually looks like down there and how you figure out, what the geology is 4 kilometers below the sea surface. So we'll get into that, but let's start with where you come from and how you got involved in deep sea mining in the first place.
Well, I come from a place which is as far from the ocean as it gets. So I come from Kazakhstan and from the southern part. And I recently learned that there is such a thing as a pole of inaccessibility, which is measured by, again, the distance from the ocean. And I grew up nearby. So I didn't have any ocean insight. I also didn't have any exposure to maritime professions at the time. So it wasn't planned, let's say, to join deep sea exploration from my childhood. Although it sounds like a really nice dream to explore deep sea, I must say, but I wasn't that lucky to know about that, to dream about it. But so I didn't have any grand plan either. So I knew that I wanted to work with something technical because I enjoyed math and natural sciences. But at the same time, I wanted something that is really tangible, something that I could see as a profession, let's say. So I chose geophysics.
Sorry, where did you study geophysics? Was that in Kazakhstan?
No, it was actually in Siberia, in the middle of Siberia. The place is called Akademgorodok, which is literally academic town that runs a university, and I think it's like a few dozens of research institutions in a very teeny tiny place. So that was a really interesting space to be at.
Is that common from Kazakhstan to go to Russia to study?
Yes, I would say that to a certain degree. I think in over the recent years, China got really popular for people, again, thinking about their careers, because I know many school children who learn Chinese and kind of see their careers somewhere there in that hemisphere. But for me, it was about sciences, and Russia was kind of a natural choice then. So,
sorry, I get distracted by this, but how does that work linguistically? Do you speak Russian also?
Yes, I do. Actually, because Kazakhstan is a former Soviet Union country, so we had Russian at school, and that was the main language that we used to communicate. But of course, Kazakh is something that we learned at school, and it had its place in there as well.
Okay, so you went from as far away from the ocean as it gets in Kazakhstan to also far away from the ocean in Siberia, and then from there to Trondheim in Norway. Is that right?
Almost. So I had a pit stop in Moscow where I did my master's degree. So it was a kind of northwestern drift for me. Not that I planned it specifically, but I got closer to the ocean, that I must say. And yeah, and anyhow, that of course, ocean always fascinated me as something very abstract, but I never thought about the ocean as a career. And I think it is through exposure to oil and gas industry, I got aware actually about Norway being the country where, the technology is superior and, many of the geophysical breakthroughs are happening. So I happened to come across this PhD position advertised by Norwegian University of Science and Technology, NTNU, in Trondheim, where you are. It was about geophysics and applying geophysics to studying the subsurface. But it was in a very peculiar place. It was in the deep ocean. So it was deep seafloor or mid-ocean ridge studies project. What was kind of a big hook for me was the promise of research cruises as part of this PhD project. So I jumped on it immediately when I saw it. So that was my entry to deep sea. But also I should mention that NTNU at that time ran this deep sea mining research pilot, which you're aware about through Steinar Lefman, one of your guests.
Also, my PhD supervisor is Espen.
Yeah, right.
Right. And he was in that. I think he was in that program with you also.
Yeah,
as
absolutely.
The philosopher.
Yeah. So there you go. And for me, that was the first experience of multidisciplinarity, as it should be, because again, it wasn't just in the domain of geosciences, for example, or something that close enough to each other. But we had as you mentioned, philosophers, historians, arts majors. I'm not even sure how to describe that project, but it was a fascinating one for sure. And then, of course, engineering and geosciences as part of that. And I think it was a really interesting experience, and it shaped my thinking around the topic of deep sea minerals to a large degree, for sure.
And maybe just what specifically were you researching there? I just think it's a bit interesting to find out, like, if you were doing new research on the geology of, I guess, sea spreading ridges. What's the edge of the known science on that? Like, so this was, I guess, whatever, from 8 years ago to 5 years ago that you were doing this?
It was a very specific thing, which is hydrothermal fluid circulation in the crust. And we're talking about multiple scales. So I know that listeners may be aware of hydrothermal fluids as something that comes out of these black smokers, or white smokers for that matter, the chimneys that shape seafloor massive sulfides. But for me, it was definitely a part of the research, but not the only thing, or not the main focus. I really worked on multiple data sets, geophysical data sets, different methods. So we had seismic data, we had electromagnetic data, and I could go into details, but maybe it's not as important. The most important thing is that I try to kind of combine different known methods and what can be actually applied to that environment to analyze what is out there in the subsurface, to understand how the structure of these ridges are and what happens in the subsurface in terms of this very peculiar process, which is a hydrothermalism.
Mm-hmm.
And it was a very, very interesting project, to say the least, because it spanned also multiple scales for that matter.
Yes, so you were trying to combine different data sets, different methodologies for kind of seeing below the surface of the rock, essentially.
Absolutely.
Whereas other people had used electromagnetism, or I'm not sure what, sonar or something.
Yep.
Each of these things gives a picture on its own, and your job was, okay, let's see what happens when we try to combine all these pictures together. What can they tell each other in order to get more understanding than we would get from any of these pictures on their own? Is that right?
Absolutely. And I would also add that this is really the only way that you could learn something about the subsurface. As much as we want, there is no silver bullet solution, one method that would tell you everything. Because in geophysics, we really work with remote sensing. And so not the direct measurements, but we use modeling extensively and inverse modeling to understand what's beneath this sea floor, which we don't see per se. You have to combine different methods, understand different physical contrasts to inform yourself and to define what's down there.
Interesting. It's also interesting that you did that as the geology part of an interdisciplinary project. So you're also like at a more macro scale, you're working with other people across completely different fields to look at the same question of deep sea mining and say more about what you took away from that, from like the transdisciplinarity of that. Was there actually benefit from having a philosopher and a historian and an artist in the same office as you, I suppose?
Absolutely, although we didn't sit in the same offices, unfortunately. We just met once. I don't remember, was it once a week or no, probably it was less often. But anyhow, the discussions that we had, they certainly benefited me for sure. And again, on multiple levels. So first of all, you get to learn to communicate your research to someone who is not familiar with any of it. You get to learn to communicate what you are doing and why you are doing that, and to people who don't know even the lingo that you're used to. And then when it comes to kind of methodological aspects as well, approaching such complex topics as deep sea minerals and deep sea mining specifically, I don't see any other way except for really kind of embracing different aspects of the topic and trying to learn more about those different facets of the subject before you can really talk about the implications of your work for that big project, big topic, I think. So you get to appreciate those details. You get to learn a lot about where maybe where you might interface this or that profession and why it matters to do your work on that kind of.
That's interesting. That you get practice in and sort of justifying your work and seeing what it is about your work that's actually important to the broader field. That sounds, I think that is something that a lot of us who work in sustainability struggle with, actually, is like we are so used to being in a little bubble with other people who think that, sustainability is really important, and whatever little piece of it that we happen to be researching and the details are really interesting. And then when it comes time to trying to sell that work into industry or into politics or come up with the next research project that can be useful to people who actually have to interact with the real world, we often don't have very much success because we haven't spent much time thinking about or explaining why what we do matters.
No, surprisingly, actually, the discussions that we had with this group, they weren't very shallow, as you would think that us not having very much in common would have very kind of plain discussions. It ran very deep because the questions were fundamental. We're looking for something that connects, or I guess the connection points are naturally deeper than something that similar disciplines would have. So that was a very interesting experience. But also for someone like maybe jumping into the work that I later did with Argeo, organizing different exploration campaigns. These are also multidisciplinary activities. And without that exposure to at least the discipline of biology, which we had in all of these research cruises, I wouldn't really know what would be of interest to that group. So naturally, I wouldn't be able to plan for that, or I wouldn't be able to account for that when choosing the survey pattern or choosing some specific elements of the program. Yeah, I think the exposure to different disciplines can only benefit you in that respect.
I guess this is a little bit of the hedgehog versus the fox concept, where you are either super up close and detailed deep into your subject, or have a broader perspective and they say that they've done a research saying that it's people who kind of can exist at the interface between disciplines that do the most breakthroughs, win the most Nobel Prizes, etc. Because being able to switch a little bit between very deep and also being able to see how you connect to other things is important and I guess rare.
But honestly, I think it is in many ways a false dichotomy, because for me as a geophysicist, at least, I should always care about context, because it is science that works, or the methods, geophysical methods, they work on contrasts to surrounding rocks. So we have a target, and unless we know what's around it, we wouldn't know what sort of contrast should we expect. Is it positive, negative? So for me, it's kind of natural to always zoom out and see where we are, what's around me, and how it contributes to the signal that I see. So yeah, I think we should do that more often for sure. But I understand that practically, time-wise, you have to drill into certain subjects, and you don't have enough time to go a little bit outside of that, and let alone to different or other disciplines. So that's why maybe designing it into your workspace, that's how it's best done. Especially when it comes to decision makers, if there is an office where these people get to meet each other, that's already kind of half job done. So maybe that's the secret, or whatever the component that is missing.
Interesting. Often. Okay, so then take us to what you've been up to since your PhD. So for the last 5 years, you worked for Argeo, and for the last few years of that, what was your position was specifically in the deep sea mining department?
I started as a geophysicist, and I worked on different projects in offshore domain, oil and gas projects, wind farm projects, so everything that had to do with seafloor mapping with robotic solutions, because that was kind of the specialty of the company. But then I gradually started leading the deep ocean exploration initiatives in the company first, and then it morphed into a marine minerals department that I worked on. So it was mostly about deep sea exploration campaigns that we got to deliver or work on with the ISA contractors or national bodies like NOD or Offshore Directorate for that matter.
So tell the listener what exploration campaign is. I mean, I think it's pretty fair to assume that there's a very small number of listeners who have some idea and have maybe even participated in exploration campaigns, and the majority of us kind of know that, okay, you got to get out there on a boat and, use some sensors or some robots to get some information. And there's a lot of bragging by the deep sea mining companies about how much information we have. There's terabytes of data, and you can go to the ISA and look at it. But explain just kind of for the layperson what this looks like, what you're doing out there and why you're doing it and what you're looking for.
Yeah, happy to. And interestingly enough, I would like to start with the fact that since my experience involved both research cruises done with universities and led by universities, and the commercial projects, exploration campaigns that you described with the ISA contractors, for example, they really have a similar rhythm to it, because it always involves a vessel. We always need to go somewhere remotely, and we need to mobilize different equipment. And the equipment that is used is oftentimes the same, except for commercial projects. There might be more advanced tools, but not necessarily, because oftentimes research institutions also test some prototypes, and then you get to work with some interesting technology that is just not scaled yet. But largely all of these projects really start even before that. And it starts with planning of the project, where we go, why we go, what are the goals. And that's very, very important, because that defines the choices of equipment that needs to be mobilized on the vessel. But anyhow, once you're there at the port, you need to work on fastening all of the containers and other loose pieces around the ship. And of course, you will have all your high-tech secured, so that you can withstand the rough seas, which happens to be often in the far areas of the ocean where we operate. But So after mobilization, you steam to the site of interest, area of interest, and then you start with calibration of all your sensors before you dive into depth, because that is really important to make sense or to synchronize all of your data, let's say. And depending on the goals at hand, you would be deploying the equipment that you have. It's either ship-based equipment. You can lower something directly from the vessel. For example, if you want to measure some water properties, then you can use remotely operated vehicles that are tethered again to the vessel. And if you want especially to see or explore the seafloor with your eyes, although through the equipment, of course, because we don't get to be there without the means of technology. Or it could be autonomous underwater vehicles, which are, as the name suggests, sent there using pre-programmed missions. And then
that's actually probably something worth being explicit about. So, because people are aware that we have manned submarines that go to depth. Alvin and gapping on the one that was in the news a year ago for
Titanium. No, Titan. That's the one you're thinking about, probably.
And that is not part of the kind of exploration that you're involved in, right? It doesn't make sense to put people in a sub and send them down there.
I mean, it does make sense for certain projects and for certain aspects of that, but no, not on a scale. Not if you want to cover large areas. Mostly it's done through science, of course, but it is possible in principle. It's just not what we do for the sake of time as well.
Mm-hmm. So you've got remotely operated underwater vehicles. You've got autonomous underwater vehicles, which just kind of guide themselves around collecting information. Are you, so in a campaign like this, you're looking for the geology, you're obviously mapping out the surface, you're trying to get some information on what's under the surface. Are you also working on the biology at the same time, or do those things get separated out into different camps?
That's a very good question. And I've been working a lot on strategizing around that and really making sure that we always do both, or we at least think about that, about which sometimes byproducts can we get that could be useful, not immediately, but maybe later on. I think that's just a good practice. But yeah, in that way, we are, of course, focused on the seafloor to a large degree, because oftentimes the resource mapping is the primary goal. But at the same time, habitat mapping happens in parallel. So we're not limited in terms of what we can use the data for. But the question is, of course, that we have to make some decisions around data collection and know what the primary goals are, because there are, as you care about, there are many trade-offs that we have, that we face at that stage. Because should we map something, even as simple as coverage versus data resolution? So for geology, we can go about with meters of resolution, but for biology, of course, that's not enough. We need to go down to centimeter and millimeter level. Do we use the time that we have, the ship time, to collect the high resolution data immediately and spend more time on that, or we try to cover bigger areas so that we know more about the context and about the substrate of those for those species? So these are always the questions that we ask ourselves at the planning stage. But of course, you cannot know everything. And that's where it's a very, very dynamic environment, because we have to adapt our decisions as we go, as we discover certain things, and maybe some interesting observations pop up. So we have to. Yeah.
So it's trade-offs all the way down. You're even in the moment having to balance between resolution and coverage and costs. And obviously, it's not just a question of costs. It's you have a limit. So if you invest in more resolution in one area, then you're just going to miss out on information in another area.
Absolutely. So ideally, we want to optimize everything in terms of value of information, right? We want to always add information that is that doesn't repeat itself, right? That always gives us something new to contribute to the big body of knowledge that we're trying to build. But it is challenging because oftentimes you don't even know which questions you should ask yourself, because these environments, they are not as systematically studied, actually, even though there is lots of data, but we don't always know whether we will discover something new or whether it's going to be just another location that we will contribute, right, to the coverage of. So yeah, there are many trade-offs for sure.
Okay, so then yeah, I mean, I'm not exactly sure what the right questions to ask here are, but I'm interested in knowing what the kind of, I don't know if data pipeline is the right word, but you from getting the actual data to doing something with the data. Obviously, there's a bunch of steps and decisions that get made, and any kind of, if you can just kind of lay out that map of like, how do you go from the one to the other, and what decisions you have to make along the way.
Yeah, and I think that's, at least in my career, that's the most important kind of part of work, is really being acutely aware of this pipeline, knowing that this data set that we're looking at to make the decisions, and oftentimes these are colorful maps, right? These have their history, right? All of the data has its story along with it, the assumptions, the limitations, the decisions that we made at the time of survey. So yeah, I mean, we could start with the survey planning, because usually if you have a point or area of interest and you have the technology that is really fascinating in a way that it operates, and I'm talking about autonomous underwater vehicles. It's not magic, right? Pre-program, we have to pre-program them and provide some information in order for them to dive into those areas and collect the data. And oftentimes we have to provide the survey patterns, the altitudes, the speeds that we want the data to be collected at. So these are the decisions that we already make at the time of data collection, right? So after
let me stop just for a second. You already have some knowledge, like you've got at least a kilometer grid scale or something of what this looks like, and then you have to make decisions about, even at that point, you're like, okay, we want finer resolution. We've got a bunch of decisions to make about what depth to, what altitude to set our machine at, what speed, what resolution. So it's interesting to think about how you're starting from a point of certain uncertainty. You're starting from a certain level of uncertainty, and then you have to decide how to even start filling in the picture.
Yes, and it is a big decision, because you can go about these decisions with from different perspectives. You can zoom in, zoom out, and at least in mineral exploration, there is a mineral systems approach, right? When you start with regional data and you just gradually zoom into what are the interesting pieces. But perhaps in deep sea minerals, oftentimes we have, for example, an active hydrothermal area, and we know that most likely around that area, there could be something that is of commercial interest, right? Inactive sites, seafloor massive sulfides. So we would go in that area specifically immediately with the high resolution data collection. So that could be another kind of side of spectrum. But yes, you have to make those decisions, although it's not as complicated because of the technology again as well. Because with autonomous underwater vehicles, you don't have to manually choose all the altitude points or whatever trajectory. You can have the pattern, and then you have sonar systems that help the vehicle to navigate the terrain. So they will be automatically kind of reading the terrain and putting you on the specific altitude or in the specific position. So for that matter, you can run it safely and you can have an idea of what you're doing and how. But yes, you still need to decide which way you want to go, across the slope, along the slope, or how close to the seafloor you want to be, and how fast.
And I mean, suddenly you might run into a much steeper slope than there might just be a cliff or something in front of the vehicle that you didn't know about before you sent it down there. Just so I have the impression that mapping for nodules in an abyssal plain is going to be just a lot simpler than mapping for seafloor massive sulfides. Like the nodules are fairly easy to kind of see. You know what's down there, and you can identify the characteristics that will be meaningful for planning the next phase of the campaign. Whereas for SMS or I guess crusts, there's a lot more to it. There's a lot more uncertainty. There's a lot more information that you are really trying to dig out of this campaign. Is that right?
Yeah, that's absolutely right because of two things. So seafloor massive sulfides and crusts, although crusts to a smaller degree in a way, are the deposits that have the third dimension into the subsea floor, the part that we don't see. And nodules are detached from the surface and they lay on the seafloor, right? So that's something that is already just visible through optical methods even. That doesn't work with sulfides or crusts. And then another thing is the terrain itself, because nodules, they form on abyssal plains, which usually there is some terrain, there is some, of course, variation to the terrain, but it's within, a few degrees, maybe 10 degrees oftentimes. But with seafloor massive sulfides and the crusts, you're looking at very, very steep slopes. So we're talking submarine mountain chains, right? So you have to be careful with both the equipment, how you collect the data, but also in a way you have to plan that so that you can highlight the parts that matter most in a way in the subsurface. Yeah, I think there is a huge difference in the way that we run these campaigns for sure.
I think that's a good imagery. I think a lot of us are used to looking at the kind of more simple images of deep sea floor, which is kind of more flat and more regular. And so then when you're looking for SMSs, are you just like kind of in the underwater Alps and it's jagged and it's rocky and it's very complex?
Yes, oftentimes that's it and actually there could be cases where it's milder, of course, and geologically speaking, there are such formations as core complexes, and that's where you have kind of the upper crustal rocks exposed through this giant fold that is more flat and not as extreme as other parts of the mid-ocean ridge. If we put that aside, oftentimes that's what we deal with. So yeah, oftentimes we're working with this extreme environments, and yeah, that's where most fun is.
Yeah. I want to get back to the information pipeline, but I guess it occurs to me that I think a lot of listeners don't know how hard it is to identify kind of zone of interest in terms of a seafloor massive sulfide. These are often kind of described as it's like a mound of minerals where there had been venting activity for a long time that then just extinguished and everything is kind of settled out. So it could be that those mounds are just kind of easy to identify. They have a regular and recognizable shape, and you can kind of pick them out from a distance and focus on that. How is it actually to find what's interesting down there?
So historically, as I said, most discoveries are made in the vicinity of active fields because that's where the attention goes of all of the research campaigns, and that's kind of what both scientists or multidisciplinary scientists are actually drawn into naturally. But for deep sea mining, it's only the inactive sites that are of interest. And not only from environmental perspective, but also the seized activity is a proxy for maturity in a way. So you want to have a more mature deposit that will be bigger and So there is that aspect to that as well. And as you said, there are cases when the mound or the bathymetric shape is really something that you can recognize and almost certainly identify as a seafloor massive sulfide mound. But it's not that often or often enough in our biased data library because that's how naturally they would be identified. And those that are hidden out of sight, they wouldn't be as easily identified, and therefore we would know less about that. But luckily we have the geophysical methods to work with. And as I mentioned before, we work with contrasts, and in this case we rely on physics. So certain metals, they will have specific properties that would be kind of visible in either magnetic data or electric field data or electromagnetic imaging. Sometimes also seismic methods help us to distinguish those because they have contrasts in, again, properties of the rocks or even structurally sometimes there is a big difference. So we would use those methods to identify these deposits. And that said, there are many false positives and false negatives that we face in those realms because we don't know with certainty unless we sample the rock.
Which involves sending down a drill coring machine, and that's a lot more.
Although not necessarily. So that's the ultimate ground truthing, of course. We need to drill down into the subsurface, but there are, of course, some cues on the surface that you can spot with ROV video cameras, for example, or you can use AV imageries as well. So sometimes like the sulfides or the sulfur makes yellow color that is recognizable, and then you could spot that and hints that you probably have some sulfides somewhere in the vicinity, or green colors as well, beautiful copper hints that could help us. But in many cases, you need ground truthing to say for sure whether it is a deposit of your interest or not. Because oftentimes, again, there could be just different volcanic rocks that would create this similar contrast, or it could be some transient effects like water saturation or something else that would mimic the same signature, but it wouldn't be the deposit that you're looking for. And of course, if you choose, or if you are unlucky to choose ill survey parameters, you might just miss the deposit because of a failed resolution, or too big of a spacing between the survey lines, or too high of the altitude, or whatever is the case for that matter.
It's interesting to think that the positive samples that you get are the ones that were the easiest to find, and so that's going to bias your data. It's like
it's very common, because we just like,
yeah. It's like how they what is this story about how they believe that dolphins have a propensity to rescue people who've fallen out of boats, but you would only get the stories from the people who happen to have been rescued by the dolphins. The stories from the people who the dolphins put in the other direction out to sea.
The survivor's bias, the classic one. So
then I will let you get back to the data pipeline if you have any memory at all of where you were. You talked about how you kind of have to start with planning out what data you even want.
Yeah. And we talked a little bit about choosing the parameters for survey or for data acquisition itself, right? So that's very important, something that affects how the data looks like. But of course, after you plan that and you collect the data, there is some processing. And there's always some processing. So we rarely work with raw data. Maybe for water properties, I would say, but not even that. You do some processing and calculations along the way, and you have to be aware of that because oftentimes that involves calibration of the sensors, especially when it comes to water chemistry. If you don't calibrate your sensors, and oftentimes you have either electrodes or optodes that help you measure this, like salinity and turbidity and concentration of different gases like methane and oxygen, then you would get some very abstract results. Maybe you will nail the relative component, but the absolute values you would always be off, and you wouldn't be able to say much or to compare different areas, for example. And similarly with bathymetry, the simple data that we're all used to, it relies on us calibrating the sensors on the sea surface so that the navigation is correct, so that we know that we are in that place where we were, and we can repeat the survey, or we can compare that survey meaningfully to something else. We don't think about that often because that's kind of baked into that data set that comes, at the other end of the pipeline. But sometimes there are errors even there, and depending on what kind of decision you're making, how meaningful it is to you, these kind of uncertainties around the data sets, then you have to check that as well, or you have to be aware of that at least. Yeah, and so data processing, that follows, of course, data acquisition. And depending again on what type of data you're working with, the timeline for processing can vary a lot, and that has to do with the amounts of data. As you mentioned briefly, there are like terabytes is something that we're dealing with, but that is really true for some of the more advanced data, such as the synthetic aperture sonar data, for example. The data sets that provide us with centimeter level detail of the seafloor in terms of backscattering strength, quality of the seafloor, let's say, they come in terabytes. And you have to be able to process that. And as you understand, it's not done manually. You have to rely on machine powers to do that. And therefore, the timeline for the seeing or identifying something that you acquired just now will differ for these different data sets. I'm a fan of really adaptive approaches while you are at sea, because you don't get that opportunity as often as you would like to have. And if there is some discovery, important discovery, you want to kind of notice that as soon as possible, so that maybe you can revisit it, maybe you can collect some complementary data to verify that, and that requires a lot of attention to the data as you go. And I think that's what at least that's what we have been focused on at Argeo, in kind of optimizing that timeline and making sure that we can afford those decisions while we're down there. And yeah, that involves a lot of work, a lot of communication, including onshore, offshore communication.
Mm-hmm.
So likely currently there are different satellite connections available. Before, it used to be much more difficult, of course. You wouldn't be able to send so much data back and forth, but nowadays we can do it from the office as much as offshore, which helps a lot.
Fascinating. Yeah, I never thought about that, the delay in actually getting the picture that you're taking as you're taking it. If you've got to process all that data and there's going to be a delay and you need that data in order to make the next decision, that's not something that is kind of obvious when I'm thinking about how I would navigate the seafloor with my autonomous vehicles. But
that's also fair, because I guess many people are used to working with bathymetric data, and that is really relatively quickly processed. You can have it within hours. And even actually, we had some real-time processing on the AV itself. So you get the map out of the AV once you get it out of the water. And so that could be the case. But the thing is that data set alone doesn't provide you with all the insights. Oftentimes you need to have the geophysical data processed and other complementary data sets processed in order, or combine all of the data sets to see something very important that you wouldn't see on one data set only. So that involves a time component.
I assume it's also not simple what you're looking for. Like you're going to get this feedback as you're doing this, and you're going to get some indications, and you have to make some guesses about what those things mean and make a lot of decisions with only limited information.
Yeah, what you refer to is really what we call interpretation of the data. And we have to remember that we only interpret the data, and there are many interpretations of the data. So, of course, we try to make the most informed interpretation of available and use all the constraints to help us. But we cannot be certain about that, because we haven't drilled those deposits or whatever you're interested in. So yes, that is an important part of the pipeline. And in many ways, we do have enough understanding, of course, to make those informed decisions. But especially when it comes to multidisciplinary communication, you have to mention the assumptions that you make along with those results. Because oftentimes the interpretation really relies on the assumption of this or that we think that this is this type of rock, or we think that this is that type of rock. and only in that combination that it would make this result or this interpretation viable. And we always have to provide alternative interpretations, if any, because it's easy to get overly excited about some anomaly on your data, but sometimes it could be just technical or equipment error that you're trying to overinterpret. That's unfortunate, and that's where you need to have specialists who would check for that and tell you that no, this is not an error. This is a signal. It's not the noise.
Yeah, probably good to have a few different sets of eyes, even just to balance the kind of human tendency to see something like, those, what do you call those? Maybe it's a rabbit or a duck. And once you see the one, then it's very hard to see the other one. And so if you're interpreting data, and especially if you want to find something, and you see that you've found what you think you're looking for, it must be just mentally difficult to then open your mind up and think, okay, what else could this be that I'm looking at?
But that's where, as a professional, you have to have this on your mind all the time, and you have to have this best practice. Because even with the tweaking colors and choosing the different color scales, you can highlight certain things, but it wouldn't mean that you highlight the true things. It would likely mean that you're making an artistic interpretation and you're making some, rather artistic point and not something that is tethered in real physics, because you have to, again, go back to the original data, where it was collected, how it was collected, and check all of these things before you can confidently say anything about this. And even then, you shouldn't be confident 100%, because as we mentioned, there is uncertainty always around the data. You have to be humble about it.
Okay, and I guess my next question is just kind of what's the next step? So you've got the data, you're interpreting it on the boat, you're trying to make decisions about what the next bit of data to collect is going to be. You go through that process. At some point, does that kind of cover what's happening in the cruise? This is just a bunch of iterations of planning, collecting, interpreting, and adjusting. And you just kind of do as much of that as you can until you run out of time or budget, and then you take what you've got and head back to shore.
Yeah, I'm glad that you mentioned that time and budget bit in the end, because in simple terms, yes, that's how it happens. But of course, all these iterations, they are costly, and you have to remember that. And there has to be a certain level of trust also between if we're doing it commercially, between the customer and their idea of what they want to recover, what kind of data, what is the ultimate goal for them. Is it, again, to map the seafloor a certain area and map everything to a certain degree? Or are they willing to go and chase the discovery or the potential discovery and work around that? So that is something that, of course, you cannot predict when you are in the pre-planning stage onshore. And this happens dynamically offshore. Again, if there is enough trust between the parties, and if there is a good communication about of the results, then it can be adaptive and you can optimize certain things, but we always pay the time tax, right? The ship time is really expensive if you think about it, and you have to have your big goal, and you have to also be strategic around that. You cannot always chase the discoveries. It will lead you, nowhere in the long run, right? So I think that's where it would very much depend on who is offshore and who is making those decisions right there and then.
I feel like I should have a little bell that I ring every time trust comes up on this podcast. This conversation with you is very interesting, because we're talking about the technical data gathering aspect of this field, which is very controversial, kind of in its normative, and it's like, should we, shouldn't we, the impacts, the societal decision making. And that's where I think of trust and trade-offs coming up. And I'm seeing that there's like this fractal whatever, as we look at one particular piece of this puzzle, we're also just running into these issues of trust and trade-offs, even to kind of chew one little bite of what we need to do in order to make the deep sea mining decisions.
Well, to that, I just wanted to maybe add one thing is that this is because this, I don't know if I should call it an industry even, is really immature. There are not that many best practices developed yet, although there are some, certainly, and we adopt many from other domains, but it's just not as established. And that's why we need to always kind of check ourselves and make sure that we're doing the right thing and we're doing the most optimal thing for that matter. But, in more developed industries, that's just handled through all of these best practices and standards that we have to follow. So I think that's one of the things that we're seeing, because many of the things that we are doing is new, and we just have to learn by doing, and then try to also communicate our results and observations so that the next ones can account for that and use that.
Yeah, when you're doing these cruises, you are trying to solve a problem in front of you. You want to get information about the particular area of seafloor that you've kind of been assigned to map. And then you would also want to be developing best practices. And is there sometimes a tension there between kind of doing the job that's in front of you and also putting the time into developing the field or developing the like recording what you think other people ought to do the next time they do that? Is that a sensible question?
It is a sensible question, and I think the ISA is doing a good job there, at least if you follow their guidelines, because they require you to report on certain things. If you have any, observations during your campaign, be it, the interference of technology and the environment or anything else. So I try to do that to the extent possible, to communicate whatever we observed, and so that the next campaigns would account for that. But also, generally, at this point, this is the role of conferences and research papers and white papers to communicate that, I think.
And having worked in industry, is there always it's always a struggle to make time to go to the conferences, to make time to write out the white papers? Is there there must just be a bunch of information that's sitting there in people like yourself who've been working in this but haven't got the time. No one's giving you a month to sit down and write the stuff out and publish it somewhere.
It's like anywhere else. Really, it comes down to a person, to a specific, timeline and whatnot. I wouldn't say that it is encouraged, I think, because it is a small community, and again, you have the opportunity to make that impact, I think, if that makes sense.
Yeah.
So naturally, you want to do that because you know that it matters. Again, unlike in some more mature industries where it would be just minor things. But at the same time, you're merely humans. And if you don't have the time, you just, some things get lost, unfortunately. Or they stay with a specific company, for that matter. Usually that's how it is.
Yeah. I feel like since we kind of touched on the trade-offs, and I should take this opportunity to just kind of ask you my standard question that I have to ask everybody about how we make decisions in the situations of balancing trade-offs between different value categories. I mean, you said a number of things already on this, but I want to give you the opportunity to just talk at the macro scale, having worked in deep sea mining for as long as you have. Do you see this issue of trade-offs as being present and pervasive, and how do you see the emerging industry best handling that going forward?
Yeah. So as we touched upon, I do see that, every level pretty much of that data pipeline. And as we know, or ideally, data should inform the decisions, and all the decisions should be based on the data that we recover from these areas. So therefore, these trade-offs, they kind of extend into those domains on the macro scale. But at the same time, I think that if one tries to maintain the holistic view and think long term and think, in terms of value chain as such and in their decision making, then certain things may not be as critical, as long as, back to trust, as long as you have the trust in the pipeline where that every professional does their work and communicate the results to the extent possible, along with, again, limitations, uncertainties, assumptions, and everything else, so that you can just put this into perspective, but not necessarily get stuck with it. Because it is really easy to get stuck with these micro decisions and never uncover the big picture.
I guess I want you to say more about you. So you sort of suggested that some trade-offs appear. I'm going to say this, and you can tell me what I got wrong. Some trade-offs kind of like appear to be very serious, but as you fill in more information, as you let the process go to the end, then there's a resolution that happens naturally that you don't see as being possible where we are now in the process. Something like that. This was, I got like a glimpse of an optimistic insight there that I hadn't heard before, and I just kind of want you to go back over that and explain more what you meant.
Yeah, I guess I am an optimist in that sense, and I tend to trust that we are a community of professionals, although of course there are different actors everywhere, good and bad, but at large, that if everyone does their job, then we kind of gravitate towards something more, I'm not even sure what the word is, more truthful, or something that we're looking to describe and make sense out of. In that, I do think that we just need to learn to communicate the results, whatever we are working with, so that the next person making the decision has that on the back of their minds, and then we can kind of resolve the trade-offs, or be aware of those, and kind of just turn the tumbler here and there. But in the end, that would be something that we see as a big picture of certain trade-offs, but we move somewhere forward, not backwards, and we're not doing it out of motivations and whatnot.
Yeah, I mean that makes sense, and it's obvious kind of once you say that. Like, yeah, if you've got when I like picture this deep sea mining vague trade-off issue that I kind of am trying to wrap my head around, it involves a lot of uncertainty. It involves a lot of values that I always keep saying are difficult to compare to one another. But you're right that, for one thing, if you gather more information about those things, and then, like you say, if you communicate that if you've got one set of experts who are very interested in one aspect of this problem, and another set of experts who are interested in something on the other side of whatever this trade-off balance is, then letting those people fill in, but also encouraging them and helping them to communicate across the disciplines is going to not exactly resolve in terms of solve the problem, but resolve in terms of make things clearer, get the picture better, make it easier to understand what you're actually deciding about when making these decisions.
Yeah. I guess I'm also in many ways a visual person, and I think of it, I mentioned tumblers, but also I'm used to like traffic light approach in risk evaluation, right? So you have certain layers of data or layers of trade-offs, and you can overlap them and see where you have the critical points and draw your attention there, as opposed to trying to manage all the little trade-offs and debate them and spend all your energy on those, rather than doing that with micro things that maybe you don't know actually if they matter to that level or not, because again, uncertainties can go both ways.
Yeah. So if you're putting enough of the picture together, then you can highlight the point of leverage or the critical decision points or the critical issues and really focus on what's important. That makes a lot of sense. Then I feel like I took us a little bit off track before getting through the whole process of exploration campaign. And I feel like we should at least get to what happens. Okay, so you've done an exploration campaign, you've made a bunch of decisions, you've gathered a bunch of data, and then like what happens with that afterwards?
Yeah, I think it would make sense to bring it to a logical conclusion, although our conversation kind of reflects on the chaos of the offshore campaigns as well, because many unexpected things happen, of course, and you have to sidetrack oftentimes to pursue different actions. But after that, after the campaign is over, you, of course, demobilize equipment and do all of that in reverse order. But for the decision makers, the important thing is the reporting. So we have to provide the report, and that's where actually we do our best to communicate, again, all of these things, as we mentioned. We describe the whole situation with the campaign, from the weather to all of these other nuances that may seem unimportant on its own, but as a collection of observations, they serve the final kind of providing the full context of the data acquisition campaign and the resulting data. So we put all of these things into reports along with the interpretations as we see it, if that's part of the services that we provide. And then, you just deliver that report, present the report, and in certain cases, most of the time, the contractors themselves, they report back to the ISA. So that's not our function, but that's something also we can help with, of course. And that would be it until we hear back maybe from those contractors who want to go back and continue the exploration, either again drill down into the specific deposits that we uncovered. And that happens also oftentimes after these AUV campaigns. The contractors want to go with ROVs, so that they get to ground truth the results, at least based on video footage and some rock sampling, loose rock sampling. And so that's how it's done. And after that, again, drilling could be the pinnacle of that in case we discover a deposit, and that would inform the resource estimation in the kind of final product that most contractors are after.
Sounds like it is a combination of skills that people don't necessarily think of as co-occurring in individuals. So you've got to be very technical, very managerial, and also like good at communicating. So not only to operate the commitment, meant to know enough about the technical aspects of underwater geology to do the campaign right, but then like you say, to kind of make the decisions along the way to balance all the competing motivations and aspects, and then also to communicate all of that out at the end. And as someone who works in research, I feel like the communication step is really difficult to take something that a small group of people know a lot about and then pick out what's important to communicate and make it sensible to whoever has to understand that is absolutely not easy. It just seems like it is rare to find people who are competent at all of those skills.
It doesn't have to be always one person, right? As long as there is an oversight, I think that's what can be missing in certain projects, and would be an unfortunate situation when you don't have the grand view of things happening, and then you get lost in either these nuances or you fail to connect the dots and during the campaign or after. So usually it's a lot of people who are involved for sure. And in my experience, actually, these deep ocean exploration campaigns, these are by far the favorite of maritime crew, and they really enjoy being part of that, even though for them, some operations may be routine, just steering the ship and whatnot. But because there is a lot of things involved that are, again, outside of their expertise, and we're doing something very complex and interesting, but also visual. Oftentimes, you get to see these maps, and you're like, "Wow, this is really cool." So they get to appreciate that, and because of that, you get more of a teamwork I guess, out of that, because everyone is interested in discovering something new. It excites people. And I think that's the beautiful part of this campaign. At least that's what I enjoyed the most. And that's why I cared a lot about communicating also with everyone on board about that, because you never know. Sometimes when people hear about that, what we're after and why we're doing this, they may come back to you and say, look, I noticed this little thing. I don't know if that's what you're looking for or not, but I think this is interesting. And then by kind of involving people, you get to benefit from this, again, excitement and interest. Yeah, I think that's important.
Absolutely. Okay, then, Anna, I need to be respectful of your time here, so I've got to reduce my outstanding question list down to whatever is the most important thing. Is there anything specifically that we haven't covered that you think is worth touching on before we start to wrap up?
Well, I really enjoy discussing all this, different nuances, and I think it's really beautiful that you provide this opportunity to different experts in the field, so that we fill in not necessarily the gaps, but we highlight certain things that people don't get to appreciate before, they think or they work with that aspect or data or whatnot. Yeah.
Okay, well then let me ask you about the technology. So we didn't really get into it, but deep sea mining, deep sea mineral exploration kind of is similar to, builds on other existing industries. And so there's a lot of crossover of technology from other domains, but I suppose that there's also some kind of bespoke technology being developed specifically for this. And if that's the case, that technology must still be kind of on the upward slope of an S-curve, because there's only more and more attention, and this hasn't been kind of developed for that long. So just from your perspective as someone who uses this technology, where are the developments happening? What's exciting about the new technological opportunities, let's say?
Yeah. Well, you're right that there is a lot of adopting of technologies from different sectors, and mostly from oil and gas sector. And actually before that, I just wanted to say a few words about, I think something that rubs me the wrong way is the conflating of deep sea mining and deep sea mineral exploration, especially in terms of technology.
Yeah, no, please talk about that. Yeah, this is something that I think is in the background a lot, and I'm happy to have someone talk about it.
Yeah, I mean, it makes sense, of course, to talk about both. These are kind of overlapping things in certain aspects, but in terms of technology, deep sea mineral exploration and mining are very different domains, because one has to do with, again, remote sensing and sensing in general, and the other one has to do with physical recovery of samples and material. So these are not the same, and we have to discuss them separately. So I can speak for deep sea mineral exploration technology. I believe that you had some guests who are developing some mining technology, and this is also exciting, equally exciting. But for exploration, I think the adaptation or the adapting of technology is although we always have to be cognizant of differences of the targets. So oftentimes in oil and gas, we have the much bigger targets. They have very distinct properties in terms of physics and different properties than we have in deep sea minerals. Oftentimes we need to go higher resolution, higher frequencies, and so on and so forth. So as long as we remember about that and are not falling victim to the hammer's law, where we try, when we see everything as a nail, with the hammers at hand, and really genuinely adopt the technology or highlight the potential limitations of those technologies in our use, everything goes. Really, we need to try both different scales, regional scales. Seismic can be helpful in highlighting the regional picture for us, but similarly, we can go high resolution and use the acoustic methods to kind of help us with delineation of these deposits. And so the exciting stuff happening, I think, is really in the data space, in processing of the data, as we discussed before, how quickly can we do that? Can we do that on board the AUVs already so that we make these decisions? Can we guide the AUV while at the seafloor, for example, to pursue the what we think as targets and kind of provide us more details about that?
You mean like have the AUV recognize the interesting features and have it make its own decisions about, oh, here's something that should be investigated more deeply, and have it recognize that?
Yeah. For example, making the grid more dense in those locations or things alike, so that we don't waste this time on going up and down. So at least to me, that's the exciting part also in terms of how to implement that best, because it's not a trivial task either. When it comes to methodological developments, I think electromagnetic sensing, that's something that is a must in our toolbox, but there are some challenges related to energy sources. How can we get close enough to the seafloor so that we resolve the deposits, but also so that the battery is enough for us to act as an electromagnetic source, for example, or something that would be really helpful in there. So again, there are trade-offs in terms of energy budget and what you can do while at the seafloor. So you have to kind of optimize that. But I would say that I'm most excited about the data aspects of that when it comes to the development. Because even you can hear a lot of talks, and I think Aker BP and Bergwerk are doing really great job using computer vision, for example, to identify the biological species from the ROV footage, for example. So they do that, of course, not manually, and that helps us tremendously because that saves us a lot of time, but also it provides us with some more systematic data for that matter. So yeah, I think that's what I'm most excited about.
And then this question, what are the main questions that currently need answers for the deep sea mineral sector, like in terms of broad research directions, having worked in here for a long time, seeing where people are taking it, where do you look forward to the next kind of breakthrough or the next research budget being applied to move the exploration forward?
To me personally, this survivorship bias is something that I would like to get away from. And that means to have some more systematic campaigns that are orchestrated maybe from a higher level so that we don't repeat ourselves and we contribute with the data that closes the gaps rather than provides us what's the word? I'm blanking on that. Marginal. That's what I was looking for. So in that, I think also if we manage to avoid conflating all deep sea minerals at once as one target, as one subject, that would also help a lot, because somehow, even in the professional discussions, we say deep sea minerals, but every person means a specific type, and they don't communicate that actively necessarily. And then there is a lot of confusion happening, in the public discussions because of that. But even if we look at the scale of things, nodules are huge fields spanning for thousands of square kilometers. And you have the very localized seafloor massive sulfide. Can we discuss it in the same way? Maybe not necessarily. And if we distinguish those things, that will help us a lot. And that would also mean that we will be developing the knowledge base for all three equally, or at least independently, so that we have the understanding of those and not just conflate everything into one subject that's neither here nor there. So I think that's something that I would like to see in the future more and more of.
Well, yeah, I think that's a great what do they call it? It's a great call to action to end on. So I see now, I realize we've gone way over time. So thanks for making time for this today, and thanks for sharing your expertise. I guess, normally I would ask people what they're up to next. I'm a little bit tempted to ask if you want to mention, maybe we can cut this if you don't, mention that you're looking for your next career step And so, like I talked earlier about, it's rare to have the combination of technical, managerial, and communication skills. And I think that you've got that in a very valuable combination. So anyone listening to this who thinks that they're looking for someone like Anna to join their team, it might be worth mentioning that you are looking for your next adventure.
Yeah, thank you. Thank you for these kind words, and thank you for mentioning that. I don't have any problem with it, because currently I'm on maternity leave, which is an interesting but naturally kind of a time of change. So it's perfect timing for me to think bigger than I used to and plan my career trajectory accordingly. I've really enjoyed this conversation, and that made me maybe a little bit more realign myself in what I think about further steps, because yeah, again, I believe in this multidisciplinary discussions, and because they bring clarity to yourself first of all. So thanks for that. Really enjoyed it, and I hope that it would be interesting and useful for some of your listeners.
I think it will be, and yeah, I also really enjoyed it, and I hope that we can do it again sometime, because I think there's a lot more to cover that we didn't get to.
Absolutely, yeah. Thanks.
Okay, thanks everyone for listening. As usual, if you think this podcast is worth sharing, then please share it and subscribe, give a rating on whatever podcast platform you listen on. It really helps, etc., etc. Thanks, Anna.
Thank you.
I threw my arms up and to the side.